We humans experience time as moving in only one direction, forward. You've probably never had a memory of something that hasn't happened yet. But why do we only remember the past? Why can't we remember the future the way we remember the past? Why does time only move in one direction? Scientists call this the arrow of time. It seems so obvious that time passes and we get older every second. But the more physicists think about it, the more they realize this may not actually be true. Right now, as you watch this video, there are countless events unfolding on your timeline, but you're only experiencing one of them, the one that's happening right now. You can remember the past moments on your timeline, but those moments have already passed. Physicists call this the second law of thermodynamics. It says that entropy always wins, that disorder always increases. Consider a glass of water that falls to the floor and then breaks into pieces. A physicist could describe the properties of the glass both before and after it broke and could even simulate the breaking on a computer. In both the real world and the simulation, the glass goes from being intact to broken. These particles move around randomly. Sometimes their paths cross and they collide. The paths of particles are called trajectories. And here's the strange thing. While the trajectory of a group of particles evolves over time, each particle's path can run in reverse. If a physicist took one particle out of a group, reversed its trajectory and put it back in, no one would notice anything amiss. The group of particles would continue to evolve the same way it did before. Even if you have some inkling of what the future holds, you don't remember it. One has to do with the size of the universe. Given enough time, anything can happen. But the larger the system, the longer it takes for that thing to happen. There's no evidence that the universe will ever contract. This is known as causality. Reverse time would mean that effects would happen before their causes. One interpretation of this theory suggests that time is symmetric at small scales. This means that it looks the same whether it's running forward or backward. The question is, why? Is it a property of the universe? A feature of our brains? Or an illusion? Philosophers have grappled with this question for centuries. However, as soon as you look at large-scale events like galaxies or stars, entropy kicks in and time seems to move in only one direction. Some scientists think this would break the universe as we know it. Others argue that causality would remain intact if time could reverse, because causes would simply reverse along with time. It's like waiting for a particular arrangement of shuffled cards to come up in a deck of cards. We can't go back because the universe won't allow it. Another view is that time moves forward because that's the way our brains process information. Remember the past, plan for the future, get older every second. These are all features of how we function. Neither view is correct nor incorrect. They simply describe two different realities. The more cards in the deck, the longer it'll take for that arrangement to come up. The same is true for the universe. Since it started small, it took billions of years for it to reach the state we see today. In other words, the arrow of time is set by the size of the universe. Instead, you store the information in your brain as plans or predictions. According to the other, time moves forward because our brains won't allow us to go back. It reminds us that even as we learn more about the universe, there's always something new to discover. And even when we think we understand something, there's always more to explore. Who knows? Maybe one day we'll find a way to reverse time, or maybe it's just not meant to be. But one thing's for certain, the more we learn about the universe, the more we uncover about ourselves. Both views are consistent with what we observe, but neither fully explains why. If the universe begins and ends in low entropy, and since it appears to be expanding, one might expect it to start contracting again at some point. If it does, the arrow of time might reverse, and we would literally be able to turn back time. Some theories suggest that one day our universe will reach maximum entropy, the heat death of the universe, where everything is evenly spread out and nothing changes. At this point, gravity would cause the expansion of the universe to flip, and our universe would begin to contract. In other words, time would start running backwards. This is sometimes called the Big Crunch. So when it comes time to look back on your life, you can reconstruct a narrative of how things unfolded. This is one reason why time seems to move in only one direction. Not only does the universe seem to move from order to disorder, but our brains are also better equipped to remember the past than predict the future. The trajectory of the single particle would just be reversed. But in the simulation, the physicists can also reverse the arrows of time and run the simulation backwards. When you release the balloon, the molecules move from being trapped inside the balloon to being free to roam throughout the room. But each molecule's path can run in reverse. When you bring the balloon back up to its original shape, the molecules will go back to being trapped inside. The key difference is that while the path of a single molecule can run forward or backward, the path of the entire collection of molecules cannot. The number of molecules in a given location always increases, never decreases. They can watch the pieces spontaneously form back into a glass. Even if a physicist could reverse the paths of some of the parts, the overall event couldn't run in reverse when you try to remember something. You're actually reconstructing a story from the past based on the memories you have stored in your brain. For example, you might remember what you were doing on the day of an important event. If you want to remember what you were doing before that day, you'd need to go back through your memories one by one, piecing together the story of your life. But this isn't easy to do. Remembering the future is even more difficult. because that would require a decrease in entropy, which is forbidden by the laws of physics. In reality, however, they've never seen this happen spontaneously. Only the intact glass, or the broken pieces, never spontaneously reforming into glass. The one-way trip from order to disorder defines the direction of time. You can plan for the future moments on your timeline, but those haven't happened yet. For example, the entire universe began in the incredibly hot, dense, ordered state of a singularity. Now that seems like a pretty simple explanation, but it raises another. The fundamental laws of physics appear to work the same, whether time moves forward or backward. Physicists have worked out how to incorporate entropy into their equations by giving it a mathematical value called a metric. These metrics tell physicists how quickly entropy changes under various conditions, but they don't explain why time only moves forward. Why was the universe in such an orderly state in the first place? Scientists have been struggling to answer this question for decades. It's one of the biggest mysteries in science. Then it rapidly expanded, creating the conditions that eventually led to stars, planets, and people. Over billions of years, the universe has evolved from that starting point into the messy state we see today. That means the arrow of time is set by the initial low entropy condition of the Big Bang. Is this just human perception, or a rule of the entire universe? This is my channel, and today we're exploring the amazing discoveries that are rewriting our understanding of time. At its core, time is really just another dimension. We typically use 3 dimensions to describe space: up and down, left and right, and forward and backward. If you add time to this mix, we get a 4-dimensional space-time where everything happens at a specific place and time. All the events in your life are located on a sort of timeline. Your birth, your first steps, your first day of school, meeting a significant other, having children, all of these moments are laid out on your personal timeline. But here's the weird thing: you can only ever experience one moment at a time. So why can't you experience the future the way you experience the past? Why does time seem to move in only one direction? To answer this question, scientists have turned to mathematics and fundamental physics, uncovering a concept known as entropy. In simple terms, entropy is a measure of disorder. For example, a perfectly organized deck of cards is low entropy. A shuffled deck of cards is high entropy, because there are many more ways to shuffle a deck than to keep it in order. Because the universe is made of parts that move around, bump into each other, and interact in different ways. Physicists use mathematics to track the movement of these parts as they evolve over time. And what they found is that every time they calculate the evolution of a system from the very beginning until now, the result is always messier, more disordered than the starting point. There is a clear trend toward more disorder. In other words, entropy wins every time. Physicists believe that the reason time seems to pass in only one direction is that the universe began in a state of very low entropy. In other words, we can't go backwards because we started forwards. What's even more puzzling is that physicists know of no reason why time should move in only one direction. To understand this, let's take a step back from the entire universe and focus instead on the individual parts, microscopic particles. You can see this happen all the time in everyday life. Take the gas molecules inside a balloon. They move around randomly. It's the same for stars in a galaxy, cars on a highway, people in a city. Large-scale events unfold in one direction. Now, it's not just the physical world that seems to move in only one direction. The way our brains work does. Imagine trying to figure out where you'll be in 5 or 10 years. Of course, this doesn't explain why the universe started in an orderly state, but scientists have a few ideas. This idea leads to another cosmological arrow of time. When that happens, if it ever does, time would literally be able to run in reverse, but that's pure speculation. Another reason scientists think time only moves forward is that it helps maintain the causal order of the universe. The way that causes always come before their effects. And finally, there's quantum mechanics. Some scientists think the secret to understanding time lies in understanding quantum mechanics, but so far it's kept its secrets close to the chest. At this point, it's clear that time moves in only one direction. One popular view is that time only moves forward because that's the way the universe works. According to one view, time moves forward because the universe won't allow us to go back. If you ask me, the arrow of time is one of the most profound mysteries of our existence. Thanks for watching this episode of Show Space.